The paper of the day is Leo, DB2’s Learning Optimizer. This paper introduces Leo, the learning optimizer, which incorporates an effective and comprehensive technique for a query optimizer actually to learn from any modeling mistakes at any point in a query execution plan by automatically validating its estimates against actuals for a query after it finishes executing, determining at what point in the plan the significant errors occurred, and adjusting its model dynamically to better optimize future queries. Over time, Leo amasses experimental information that augments and adjusts the database statistics for the part of the database that enjoys the most user activity. Not only does this information enhance the quality of the optimizer's estimates, but it also suggests where statistics gathering should be concentrated or even can supplant the need for statistics collection. Leo has been prototyped on IBM's DB2 Universal Database and Windows, Unix, and OS2 platform, and has proven to be very effective at correcting cardinality estimation errors. Leo requires monitoring query execution in order to obtain the actual cardinalities for each operator of a QEP. Their performance measurements on a 10 gigabytes TPC-H database show that for their prototype of Leo, the monitoring overhead is below 5% of the total query execution time, and therefore may be neglected for most applications. Now let's look at the contribution. Leo provides a general mechanism for an optimizer to actually learn from its mistake by adjusting its cardinality and other estimates using the actuals from the execution of previous queries having similar predicates. Regardless of the source of error, old statistics, invalid assumptions, inadequate modeling, unknown literals, etc., Leo can detect and correct the mistakes for any kind of operation that changes the cardinality at any point in a plan. This is a far more general mechanism than multidimensional histograms, which are limited to local predicates on columns of a database table. Their performance measurements have demonstrated that Leo can improve cardinality estimations by orders of magnitude, changing plans to improve performance by orders of magnitude while adding less than 5% overhead to execution time when monitoring actuals. Let's talk PS score for this paper. Overall, this paper is an average read, so it gets 6 out of 10 on readability. With 10 pages long, it scored 7 out of 10 on length. It's a research prototype with average description, so that makes it 7 out of 10. Its industry value in learning meter is decent, so it gets 7 out of 10 on each with overall PS score of 7 out of 10.